Hi, today we're going to discuss how to program the by using Python from the questions of Canadian computing competitions about the escape room this year 2020. So before we start the by using Python, so let's begin to see the questions. So we've been given the room m by n. This is row column. Row m column n. Okay, so, the size of the room. Say we start from the 6. So 6 has a pair of numbers 2, 3, 3, 2, 1, 6, 6, 1. Okay, so this pair of numbers means that the factors of 6, 2 times 3 equals to 6, 3 times 2 equals 6, and others as well. So, and the for the maximum of row and columns should be maximum of 1000 each, and of course these give us the total of cells will be 1 million. So we need to program in Python the maximum 1 million because the program will be recursive. So yeah, it gives us 1 million cells and recursive about 1 million for the maximum. So this is the sample input. Say the row of 3 and the columns of 4. Okay, so 1, 2, 3 rows and 1, 2, 3, 4 columns. Okay, then we begin equals to 3. So 3, it has a 1 times 3 and 3 times 1. Say I'm gonna choose 1 times 3, so it give us the next value is equals to 8, means that the row 1 and columns 3, and the next target will be 12. Why? Because there's a 2 times 4, 4 times 2. We neglect 1 times 8, 8 times 1. Okay, because the row and columns should be not bigger than that. Okay, so less than that. So so row 2, columns 4, so give us to the next target equals to 12. Then at the end we can step to the equals to 9 because the 12 has a pair of numbers 3, 4, means that there's a row located in row 3 and columns 4. So the robot can finish at the value of 9. Alright, so let's begin how to program these questions to escape the robot from the start to the finish. Okay, say we begin the library import math, then from collection import default dict, then from sys set recursion limit, comma get recursion limit. So we need to limit to 1 million cells. So that's why we need this library. And why we need this library? Because all the input must be manually input by the users. That's why we need to use the collect library. So we need to use the math library because yeah, of course it's all math. So just in case if there's a math function, so that will be easy to use if we're using the math. So here I'm going to use the Google Colab, and to define steps, default dict, okay, list, okay, position equals to, yeah, should be array. Okay, the next one we need to define the function, the next value, row column I equals to 1 while I times I less than equals to current value. If current value mode I 0 and I less than equals to max row, comma, col, and cur value divided by I must be less than 2 max row, comma, col. Okay, steps cur value, then will be append I. Okay, and then increment 1, return cur value. Okay, so this is the first function we have to define the next step from the start, say from 3 to 8, then yeah. So this is the simple function. So how to search this? So we're gonna use the depth first search. So depth first search, because why we use the depth first search? Because I got this from the slides from the lecturer when I was studying in computer science. So this is the depth first search. So the robot need to see the deepest, so because we have some bunch of the rows, 1,000, so we need to see that, we need to check all these rows until get to finish. Okay, so that's why we need to use this logic algorithm for artificial intelligence by using the depth first search. Okay, we continue again. If cur I equals n row minus 1 and cur j equals n col minus 1 should be returned to true if cur I bigger than row and or j and col or position cur I cur j in steps, return false. Then next destination equals next value. Okay, position, so we reuse the first function we made, current j and row, comma, and col. For new I in steps, next destination, new j, next destination, divided by new I. Okay, if depth first search, okay, we reuse the same function. We call the same function j minus 1 new position row and col, then or the same, but we reverse the position instead of new I minus 1 here, so we reverse to this. Okay, return true. Okay, then return false. So this is the function of the algorithm to find the goal. Name. Okay, so now we begin to define the main function. Okay, set recursion. So this is the a little bit important. So set recursion limit and because it should be limited to 1 million, say 1 million 1e6 plus 10. So we just making a little bit extend lambda because we need to define the input, the user input manually. So list number, we need to make a list in the input map int input dot split because it must be split, and n row comma n column and dimension for I. So we gotta use the for loop range to n row. Okay, so oops, I forgot to put the columns. Position dot append list number. Then we need to print, so we need to decide if this reaches the goal. The first search 0,0. So this will be reverse checking. So 0,0 here means the goal. If it's not reached the goal, means no. Okay, so yeah, let's run this program. We begin from the library. So if you guys know about the Jupyter, so this is the same thing. Oh, recursion limit. Oh, set recursion. Set recursion, get recursion. All right. Okay. All right. Then these get defining, and this is the first function. Oops. Did I miss something? Maybe typo. Okay. All right. And this is the function, the main, and this is the main function. Okay, so we check, say, row 3, column 4. Whoops. What happened? Okay. Maybe a little bit typo. Okay. Oops. Okay. No. Yeah. Oh yeah, I forgot to put the parentheses. Okay, row 3, column 4, 3, 10, 8, 14, 1, 11, 12, 12, 6, 2, 3, 9, and yes. So this is the program how to finish, to find the to get the robot finished to the equals to 9. So the robot can escape from the room, which has a finish equals to 9. Alright, so thank you. And so this is the how to program the questions Canadian competition 2020. Thank you.